So in this video, I'm going to show you how to create the OCR plumb bob, but via a different method. So we're going to use the subtractive manufacturing process, and we're going to use the CNC lathe for that. We're going to create the CAD file in TS Design, which you should be familiar with, the old 2D design. And then we'll be taking it into the Boxford Design Tools app to get it ready to basically run the program on the lathe. The plastic we're going to use is acetal, which is a great machining plastic for the lathe. It doesn't set on fire, doesn't melt, and it cuts really cleanly when we turn it on the lathe. And the only thing we need to discuss is the fact that the OCR plumb bob's dimensions are slightly longer than what our lathe can actually produce. So we've had to mend this plumb bob in a little way where it's actually going to be made up of two components. So as an example, if I show you on the screen here, the ideal process would be to have your billet sticking into the lathe there. The first process where it would turn down some of the end to the right dimensions and do the threaded internal hole on the inside. And then it would flip it around, and then on the other end you would create the cone, which would then create your ideal one-piece plumb bob, all to dimensions. But if I show you how we're going to do it, just because we don't have the length to play around with on our lathe, is we are going to have the acetal set in the chuck, but the length of the billet just for the shaft part. Then if I show you this picture, this is where the machine will cut that shaft part, leaving a tiny little 12mm shaft right at the end that will go into the hole of the head. Then we put in another billet just for the head piece, and we're going to cut a internal hole which is going to match the shaft of the other piece we've just made. And then we flip it around in the chuck and create the cone section. That'll leave you with two sections like this, and from there should be a nice friction fit of the two pieces together, and we can always add a little bit of adhesive to keep those together for this project. The only other difference we're going to make to the threaded section, because a tool has to come and obviously drill the hole first, so a drill bit comes and drills the hole, then the boring tool will come to basically extend that hole, and the diameter of that hole will increase, and then the internal thread cutter tool would come in and cut the threads. The issue we have is the threads in the design that OCR have given us are too small for the lathe that we have, so we've amended that also to pretty much do an M14 thread pattern, a fine thread pattern. So the pitch of the thread is exactly the same as the M10 which they're specifying, but it's actually going to be a bigger hole, which should match the 14mm thread. So with those amendments made, we'll still be able to create an accurate plumb bob, but there's just a few different things that we have to do to get around it. So heading over to TS Design, I want to set up the document so we can start drawing out the CAD file for the first part which we'll do, which is the shaft part. So for this, I'm going to change the layout of the page and how it works. You're probably used to seeing it just like this, maybe with a blue background, but I don't like this shadow piece on the background here because it makes it harder to see where your measurements are. So to take that off first, I'm going to go to Setup and Customize, and then Drawing Area. And then from there, at the top here, there's the Drawing Media Border Style. I'm just going to click that, and then you can click basically the no border and hit OK and OK. And you can see it's got rid of that. This makes it a little bit more neater to work with. Then I'm going to change the dimensions of this file. So if you click on the layout icon just at the top here, you can put in a user-defined material size. So for the X, for this one, I'm going to put 70mm, and for the Y, we're going to be dealing with a 40mm acetal that we're going to cut down. So I'm going to do 70 by 40, and I'm also going to put it in the design guide figures just there. Hit OK, and it's brought up the file to size. The only difference I'm also going to make is on the grid, at the moment it's set to, I think, 10mm little dots. I'm going to make that a lot smaller, and we're going to bring it into 1mm. So I've just double clicked on the grid there, 1mm, 1mm there. And I don't like the dots for this, so I'm going to hit lines and change the color to the lines to a green color. Hit OK. And now you can see your little 1mm grid for the piece that we're going to make. This matches the way that Boxford Design Tools looks as well, so it's quite nice to set this up in this way because it makes it easier if you're going to use the other platform or not. So to start drawing this CAD file, we need to put a middle line on. This is your sort of center line. To do this, you would either draw out a rectangle from the top squares to the bottom squares and find where those middle anchor points and draw a line across there. But I'm going to show you another way of doing it as well. At the moment, you may see a tiny little grey circle in the bottom corner. That's where the default 0 placement is, your sort of calibration when you're using CNC tools. But I'm going to actually change the position of this. So to do that, we're going to click on the icon next to the layout tool, which is the relocate origin, and it will show you a grid of where on the document your origin point is going to be. So you can see it's already set to bottom left. I'm actually going to select it to be on the middle right, and that will be a lot easier for this lathe process. Hit OK, and you may be able to see a little grey target has just turned up there. So we know along that horizontal line is our center line. So I'm going to hit the line tool. I'm going to click on there and go across the document to the other side. Nice horizontal line. And for a center line, it can't be a solid line like this. We need to make it into a dashed line. So with it selected, hit the line at the top here, and you can see the type. You've got an invisible line, which we don't need, a solid line, a dotted line, but then a dashed line. So it's the fourth one down here. And for the pitch, for this, I just normally put 1mm. You'll just see a nice 1mm dashed line, and hit OK. And there we've got a nice center line that's dashed. So now we can start drawing out our main points of this plumb bob. I'm only going to be working on one half of the piece. You don't have to do the other half because when we save the file, the Boxford Design Tools will understand that we're designing this for lathe, and it will reproduce it on the bottom edge. So if we know that the diameter of the part of the plumb bob here is going to be 20mm, we only obviously need to do 10mm on the top here. So we're going to be, and if any dimensions on this y-axis will be actually halving, but it won't affect the x-axis this way. So I'm going to start drawing some lines. I've got grid lock activated because this is going to snap to the grid for every millimeter. In a minute there might be measurements which are like 1/4 of a millimeter, and I'll show you the best way of doing that even when you've got this grid activated. So I'm going to start in this bottom corner. I'm going to go up 10mm, so I'm just reading the distance in this bottom corner just here, and it tells you how long the line is. So we've got 10 mils there. This one goes all the way across to 59.25. So this is where I'm going to need to either go into our grid spacing and do a 0.25 for 1/4 of a millimeter, 0.25, 1/4 of a millimeter, and then I can zoom in a little bit. Okay, and then I need to make sure I've got enough room on the screen to drag across my 59.25. So I haven't got enough room, so I'm just going to bring the slider along. You want to obviously make sure this is horizontal. So I'm at 50, 59, 59.25, and I'm going to hit there. Perfect. Zoom out again. So that's looking good. So I'm just going to bring this end line down to meet the center line. So I'm just zooming in again. So I'm going to click at the top of this line and bring it down all the way to the center line just here. At this end, we're going to have a, in total, a 12mm in diameter shaft, which is going to go into the other part of the plumb bob. We're going to do this at 5mm in length, and we're going to do it at 12mm in thickness. So half of 12 is 6. I'm just going to do a guideline and bring up my 6mm just there. And I know that where this horizontal line meets it is going to be the line I need to make. But the length, as I said, is going to be 5. So I'm going to go to 5. Oh, I was very close. I was just over. So what I can do is bring that line over one. So this is the shaft on the end. I like to put a little 1 or 2 mil chamfer just in between these two lines. So if you press and hold down on the line tool, you'll be able to go over to the draw a chamfer between two lines. And first chamfer and second chamfer distance, I'm just going to put both for 2mm and hit OK. And I'm going to click on one line and click on the other line, and you've got that nice chamfer just on the edge there. So I'm going to zoom back out. We don't actually want this line to be here now. We do for this outside edge, but this internal edge, it would just part off this bit. So we need to actually remove this. So holding down the delete button at the bottom, you can get to the delete part of an object. So if you have a look there, and you should be able to just click on it, and it would make that line, that section of the line disappear. The last part that we're going to have to work on is the internal drilled section, which is going to be 12mm in thickness, and it's going to be 22mm long. So I might do a guideline for this. So I'm going to draw a guideline from here across horizontally, and I want that one to be the 22 mils. Let me just make sure it's nice and horizontal, so I know that my line is going to join up to there. And in height, I said 12, so on this axis, we're going to do 6. There's our 6. And I'm just going to bring this line back up to meet that one. So all the lines should now be nicely joined. I don't actually need this section of the line that's in this hole. So I'm going to do the same way. I'm just going to hit the delete key and hit that section of the line. And that should leave us our nice shape that's going to be okay to take into Boxford. If we was to take this into Boxford right this minute, it won't like the file, it'll kick up an error. It's because some of these lines are all individual lines. If I click on some of these, you'll see that they're individual lines. This whole outside shape needs to be one solid path. That is definitely excluding this center line. That can stay alone by itself there, but we need to make sure this is one path. So the easiest way of doing it is selecting it all, making sure our center line is not selected, and going up to edit, you can make path there, or the Control and H, which is the shortcut, and it throws up a warning saying this is going to basically join everything into a solid one path. Hit yes, and then it says make path completed. So if we click on this now, we can see it's one nice line, and our center line is separate to that as well. If we need to make changes to this document later, if we find out we've done something wrong, I would ideally say save this TS design file by itself. The Lathe software, Boxford, won't be able to read the TS design file. We have to output it to another file type. But if we want to go back in and adjust this at any time, I would suggest saving this. So I'm going to save that now. And after you've saved it, you are just going to go down to Export File. When you hit Export File, you want to try and find the DXF file. This is a type of file which is going to include all the points that we need. It's normally a 2D plotted a 2D plotted file. Normally it'll throw up a little message just here after you go to hit save. And this is the important part, that if you had any arcs or curves, it's a way that it translates those curves to the lathe. But for this file, we don't actually have any curves at the moment. I've actually left off any chamfers and radiuses that we have on this piece because it's so much easier to do that in the box with design tools. So we've just drawn the basic shape with no fillets or chamfers, except for obviously that main one at the end there, but any smaller ones it's easier to do in box with design tools. So as we don't have any arcs, I'm just going to leave those unselected and I'm going to hit OK. This is saved, and now we're going to go over to Boxford and I'm going to show you what to do with it there. So we're over in Boxford Design Tools, just loaded up, so this is a fresh file, and I'm going to show you how to open that DXF file. So in this first section where there's a little file there, we're going to click on that. And down at the bottom here, there's a types of file, and we need to find a DXF import file. So we're going to click on that, and I'm going to find where that file is. So I can see the file is there, ready to import. So I'm going to click on that once and hit open. An import window will open. This is where you can call it something. So if I call it Plumb Bob shaft, created by Mr. Fay. And this is where we need to change some of the documents. The outside diameter, it's seeing it as 20 millimeters because that's how thick that shaft was that we made. But we've got to remember we're machining down 40 millimeter diameter acetyle. So I'm going to put 40 in there. For the length of the piece, it's put it as 64.25. I'm just going to double check what we had initially said on that one. It was 70 in total, so we're going to hit input 70 millimeters in there. And the hole depth, we did actually have it as 22, so it's worked that out from our file, which is great. So we're going to leave that as is. And I'm going to hit OK. And now if I zoom in, you'll see that it's opened it up in Boxford Design Tools, and you can see both halves of it now, so you get a clearer indication of what it's going to look like. This is where we're going to change, obviously, some of the little radiuses that I mentioned about. But also we're going to include the threaded section into this piece as well, which we do in this software. So I've just zoomed in now, and we're going to put that curved radius on the end. So there's a couple of ways of doing this, and the easiest way is to inserting a node. So with a right click on one of the lines, we're going to hit insert node. And now in between these two sections, if I hold down the right mouse button, I'll be able to drag things where I need it to be. So for this, I'm going to we'll go 1 millimeter to the left there, and this one needs 2 lines down, which equals to 1 millimeter as well. This would be a 1 millimeter chamfer, but we want this to be a radius. So I'm going to right click on it and say convert to arc, and then it moves around when I move the mouse. So I want to bring the mouse up to this side, so it's a nice external arc, and click with the left mouse button. That's made a nice 1 millimeter little radius there. Next thing is we need to add the 20 millimeters worth of thread. At the moment this hole is 22. That's because when the thread cutting tool comes inside and tries to cut the thread, we don't want that thread to be hitting, that thread tool to be hitting the back blind part of this hole. So we're actually going to just thread 20 millimeters of the section and leave the other 2 millimeters absolutely fine as it is. So I'm going to right click on this line and insert a node, and I'm going to right click and hold and bring that line down. So we've got 2 millimeters on this line, and then there's 20 millimeters on this line here. We need to now convert this part into a thread. So I'm going to right click on that one, convert to thread, and it says thread pitch. So a thread pitch is how many turns of the thread there will be in a selected measurement. So for this we want it to be 1.5. So we're going to put 1.5 in here. For the nature of this internal thread, we can only choose a left-handed thread. So that's actually going to be different to your righty-tighty, lefty-loosey type thread. This is going to be almost like an anti-clockwise thread, but that's all the option we get at the moment for this. And we're going to hit OK. And now in this diagram, you can see it's added that thread pattern to that 20mm section of the internal hole. I did forget about one more change that we do need to make to this piece for it to work properly, so it actually inserts into the head part of the plumb bob. And this measurement here of 12mm, that won't actively fit very well in a 12mm hole. It would just be so tight, there'll be a vacuum in between the two parts trying to insert, and you won't get it in. So doing a few tests, I've worked out if we actually turn this the shaft here to a 11.9mm, so 0.1mm smaller, you'll fit really nicely, and there won't be any movement or any give. So the way we do this is I'm going to hit the little icon here which says properties. I'm going to go and select this point here. You need to be very accurate with getting it on the point, and it will show you the coordinates of that plot, that part that you've just put in. So it's saying that it's on our 12mm thickness, so I'm actually going to change this to 11.9 and hit OK. And you may be able to see it's a slanted line now, so we have to do the same thing with this point just here. So I'm just going to left click on this point and do the same, 11.9. Brilliant. So now when we've created all these pieces, they should fit really nicely into one another without any issues. If we save this now just as a file, because we can edit things if we save it as a file, I'll just put shaft there. And we can also do a little bit of a 3D view. So if you go up to view and come down to launch 3D render, we can hit that one. And a render spinning out of control turns up on the screen. So I'm just going to click the letter F on the keyboard and it'll just freeze it. And I can actually bring this larger. And you can actually click and drag this piece now. So you can see here's the sort of peg shaft end that we're going to put into the other piece. And we can bring it around and you can see now a threaded hole on the inside. And you can also see that little curved radius on the outside edge there. So I'm happy with that. I'm just going to close that window down. And now we can begin to process the billet, and I'm going to show you how to do that. So as long as no changes need to be made, I'm going to click File and go down to Process Billet. So here, this is where you get to select the material that the piece is going to be made out of. The reason why we input that is it will do different depths of cuts for certain things. So imagine you had steel or aluminium. You want to do really fine light cuts, otherwise you'll destroy the tool. If you set this to plastic, which we are going to be making out of, it'll do a bit more chunkier cuts, and it'll allow the cutter to do all the work for it. So I'm going to hit plastic and wax there. The diameter we said is 40mm. That's really important because we're machining 40mm. Inside diameter, we're not necessarily worrying about that because it's not a tube. And the length of the piece is 70mm. I'm happy with that. Hit process. It'll get you to save it as a GM file. So I'm just going to hit save there. And now it's going to throw up and it's going to run very quickly through the cuts that it's going to do on the lathe. I'm going to slow this down at the moment. That was writing the G code as it was working it out, and it's finished now, but I can bring the speed of this down and start it again just so we can talk through what it's going to do. So I'm going to hit play. So it's going to do the face-off cut, and then the first drill comes in, the second drill comes in and drills the hole to the right depth. Obviously the diameter is not right, so the boring tool will come in and it will make that diameter of the internal hole larger. And then the internal thread tool comes in and it starts cutting the thread for this piece. It does it in lots of passes, so it's lots of light cuts that makes the tool not as stressed as much as if you did really heavy cuts, and also you get a finer, higher resolution cut as well. And then you'll start to see the parallel cuts, which we are familiar with on the lathes, and it's getting down that 20mm diameter. So it's doing it in nice slow passes. For this, I'm going to speed it up just a little bit just to show you. There we go. And then it's going to do that little radius at the end as well when it gets to the 20mm. Then it's going to start removing the bulk of the material down this end, ready to part it off and create that little 12mm section as well. So here comes the parting tool. It's going to come down, make that shaft, and then it's going to cut off. Then the tool goes back to a safe position and goes back to the default tool. So I can bring up a cross section just to show you what that would look like. So the internal hole there, with the threaded section, and at this end there is the pegged sort of shaft that was going to go into the head part. If I close this one down now, it's up in our main viewer, and we can actually send this to the lathe straight away. This is going to work absolutely fine as long as the lathe's set up and calibrated, and that means we can work on the next piece. So I've come into TS Design to start creating the rear part of the head. I've taken off the shadow off of the layout because, like I said, I don't necessarily like it there. You can't really see the edge of the document very well. So I've turned that off, and now we're just going to size up the document and change the grids. So going to hit the layout again, go to user defined. I'm going to put the material size in. So I know for the x-axis for this one, we're going to do 47.75 by the 40mm, which is the width of the acetal. Once again, put it in here as well. 40 and hit OK. Happy with that. And now I'm going to just change the grid. So with the grid, I'm going to double click. I'm going to go to 1mm here, 1mm here. Going to go down to lines and then turn it green. This is just personal preference. Like I said, it just matches how the Boxford one looks. And to draw that center line, we're going to move that origin to automatically tell us where halfway is, so we don't have to measure anything out. So the icon up here, relocate origin, hit the top, middle right just there, and hit OK, and we can see it's moved. And then I'm just going to draw the line across on that horizontal, and then select it and hit line, and then we can select it as the dashed line, not the dotted line, dashed line, pitch of 1mm, and hit OK. And we can see it there. Now we can start drawing out the rear part of that head. It's fundamentally just going to be a 12mm hole, which is 7mm deep. So first things first, I'm going to do my 7mm guide line. So I'm just going to bring this across. 7 is there. Cool. And then I'm going to bring that up to its 12mm. So as we're dealing with it, half of it is 6 here. Perfect. And then I'm just going to bring that line back up. There's the hole. Now we're going to just move the next line up. This goes up to the full width of our plumb bob, which is, like we said, 38mm. So we know that we've got a 40mm piece of acetal. So I'm going to move it just down to this line there, which would make it 38mm. For this, I'm going to then go across, looking at the diagram, 20mm, I believe. There. And then I'm just going to move one little section up there. So it's going to remove this part of the width and just then come upwards and finish there. Like what we did before, these individual lines that we've got, we need to make to a single path. So I'm going to select them all again. Just a note, excluding the center line like we did before. So just the lines you've got drawn here. And then we go to Edit and Make Path, or Control and H. Hit yes, and it says it's complete. So we've got one big path line there and our center line there. Like we said, if you need to come back and change this in any way, it's good to save it. So we're going to hit Save As, save it to rear head. There we go. And now we need to convert it to our DXF file. So go to Export File, rear head, that's fine. Once again, we don't have any arcs or curves in this piece, so I'm happy to not select these two. I'll just hit OK as it is. And that's saved. Once again, we can go over to Boxford just to see how that translates in Boxford Design Tools. So back over to Boxford Design Tools. I'm going to hit the CAD open file just there. Remember, we just need to bring that drop down to DXF import and find our file. Found our file, and we're going to hit open. Same prompt windows come up, so we can call that, let's call it Plumb Bob rear head, created by Mr. Fay. So outside diameter is 40, that is correct. Inside diameter, no need to worry about that one. The length, it's only reading the part that we've drawn, so it's saying that the length of the piece is 20 millimeters. For this, we do actually want to call it 47.75. Yep, 47.75. And the hole depth, that's picked that up nicely, which is 7 millimeters, that's right. So here you can see we've got our whole section drawn here. We've got the section which is the 38 millimeters. If we want to double check that, there is a measurement little tool that you can toggle up here, and you can see then the measurement does actually read as 38 millimeters, and it's saying that our billet is 40 millimeters, which is correct. This is one of the easiest bits, so it's just a case of processing this one. So you could save this here, or you can just go straight down to Process Billet. So for this one, I'm going to hit Process Billet. I haven't saved it at the moment, so I'm just going to hit yes anyway. And we're going to say rear head. Once again, we're going to put the material in with plastic and wax, and just double check that all these are correct. They are. And hit process. Save this one as rear head. And it's going to fly through the programming as it writes the G code at the top there, and it's really quickly and short. So it's done that in no time. I'm going to slow it down just so we can see it again. So if I hit play, it's going to do the face-off cut. Then it goes to the little center drill to make the center hole. And then it's going to use, I believe it's an 8.5 millimeter drill bit that's selected in the machine, and then the boring tool makes that bigger to the size it needs to be. Then the left hand cutting tool is just going to take the width down to how we want it, and that's it finished. If we close that one down again, now you'll see this okay to send straight to the lathe. Just one last piece to design in TS Design now, and that is the coned section, which is going to be the rear section of this piece you can see on the screen. So we need to go back to TS Design and design that one. So I've come back to TS Design, and I've still got that rear head file open. I'm just going to work on this because actually the billet's width in both dimensions is exactly what I need, so saving me having to remake this all. So I'm just going to delete the bit that I've drawn and keep the center line there. To do the cone section, we need to just basically draw a diagonal line, and we need to do that to the right dimensions. So I know that the cone, the full length of the cone is 40.75 millimeters. So I'm just going to go back into our guide options, and I am going to do 1/4 of a millimeter measurements, just because we're dealing with that fraction of a millimeter. Okay. Once again, I'm going to do a guideline just so I can see where the 40.75 is. I'm just going to make sure I'm doing a nice horizontal line. Oh, I'm on step lock at the moment. That's not actually going to work. I need to be on grid lock. So that's 40.25, 40.5 and 40.75. So I know that I'm up here. I'm going to do a line off of that all the way up. I'm just going to make sure I'm doing a nice horizontal line. Perfect. I can delete that other line now. That was just a guide. So I know if I go from the center line here all the way up to the top of my line there, that's exactly the angle that I need. So for this, I'm going to hit the line tool. I'm going to find that origin point and bring it over to meet that line. So that's the right angle and the right length. I'm just going to now delete this one. Don't need this one. If I was to take this to Boxford Design Tools, it would throw up an error because it doesn't see this as doing like a cut, a pass. I just need to put a tiny horizontal line off of the top of this line up here. So if we zoom in and just draw a little line from the line, just moving, so that's like 0.5 millimeter. So it doesn't really matter how long, just need to have that drawn. And it's still going to see these as two separate lines. So once again, highlight the two, making sure the center line's not selected, edit, make path or Control and H, hit yes, and OK. So that's now made it as one path. So we can save this as well. I'm going to call this cone. And we need to now export it as our DXF file. So go to Export File, DXF file selected, that's absolutely fine. Hit Save. Once again, no curves, so I'm not selecting these two, and hitting OK. And then we go back over to Boxford. So I've just opened up Boxford and I'm going to select CAD Open. I'm going to find my DXF import and I can find my cone file which I've made. Once again, it's asking for data that we're going to call it. So if I spelt it right. Actually, I'll call it Humbug Cone. Mr. Fay. So outside diameter 40, that's correct. Inside diameter we don't need to worry about. The length of the piece, obviously, it's only counting for what we've drawn, but I need this to be 47.75. Hole depth we don't have to worry about. Hit OK. So you can see it's made a really nice cone shape there. Nice and simple. We can just go and hit process straight away. So we're going to go down to process billet. Hit yes, just to save. Call it cone. Going to go down to plastic and wax. Just double check that it's 40 millimeters by 47.75. That's correct. And process. And hit save. And it's going to zoom through the process. If I slow it down as it's doing it, there we go. You can see that it's creating the G code at the top here as it's working out each cut. And you can see it's doing it in multiple passes. So it's just going to take the, I can't remember what we've set the pass for the cutting plastic depth of cut is, but we're talking like less than 1 millimeter each cut. And there we go. So that would cone that end really nicely. This will leave you with your two parts, like I showed you in the diagram at the start, and they should fit together really nicely now. And for my example, I did use a bit of CA glue just to bring them together, but yours might fit really nicely just with the friction fit. But I hope that helps. That shows you how to use TS Design to draw the CAD files, bringing it over to Boxford Tools to create it ready for the lathe. And obviously, after you've done this example, you'll be on the lathes actually programming it into the lathe and making it work. But yeah, thanks for that, and I'll speak to you soon. Thanks, bye.